Hi everyone, I'm Cheryl. In this problem, we're asked to find a cubic polynomial with real coefficients that have complex zeros 4 plus 2i and 4 minus 2i, and also has an x-intercept at -2, 0. Now, because we're looking for a cubic polynomial that is a polynomial of degree 3, we're going to need 3 linear factors. And I know that factors will always take on the form of x minus a 0. So I can begin by creating my polynomial f of x by taking x minus the 0, 4 plus 2i. And then I have another factor that will look like x minus 4 minus 2i. Now those are 2 linear factors. Remember, I need a third. Because I have an x-intercept at -2, that means that -2 is also a 0. So I can use the quantity x minus a -2. All right, so now I have 3 linear factors. All I have to do at this point is multiply them together. Now, usually it's easier to multiply the factors that contain those complex conjugates as roots first. So we're going to go ahead and use FOIL to do this. So notice my first terms are x and x, so that'll be an x squared. The outside term will be a minus x times the quantity 4 minus 2i. The inside term, minus x times the quantity 4 plus 2i. And then my last terms will be positive, and it'll be the quantity 4 plus 2i times the quantity 4 minus 2i. And then this product still needs to be multiplied by x plus 2. Well, let's keep working on that first product. I'm going to go ahead and distribute the x across in this piece, and then also apply FOIL to that last part. So I'm going to have x squared minus 4x plus 2xi minus 4x minus 2xi. And now the FOIL, I'll have 16 minus 8i plus 8i and a minus 4i squared. Minus 4i squared is the same thing as plus 4. And then don't forget your factor of x plus 2. Okay, now at this point, I should have some terms that add together to be 0. Notice that 2xi and a minus 2xi add together to be 0, and a minus 8i and a positive 8i. All the parts that had that complex number I in it are going to add together to be 0. I can also combine some like terms because I have a minus 4x and a minus 4x, which will be a minus 8x, and a plus 16 and a plus 4, which is 20. And then remember, I still have my quantity x plus 2. So notice that multiplying the 2 factors that contain the complex numbers led me to a quadratic with real coefficients. The next thing I need to do is actually multiply my trinomial times my binomial. So every term in the trinomial needs to be multiplied by each term in the binomial. So I'll start with x squared times x, which is x cubed, x squared times 2, that'll be a 2x squared, minus 8x times x, that's a minus 8x squared, a minus 8x times 2, which is a minus 16x. 20 times x is 20x. And 20 times 2, which is 40. Combining my like terms, I notice that I have just an x cubed, but I have a 2x squared and a minus 8x squared, so that's minus 6x squared. I have a minus 16x and a 20x, which will give me 4x and 40. So this is a trinomial who has the zeros 4 plus 2i, 4 minus 2i, and negative 2. Now the thing that's interesting to note here is that this is not the only answer. What could I do to come up with another polynomial that has exactly the same zeros and no additional zeros, and is also a polynomial of degree 3? Well, if you think about this first line, what could I do to change this first line? And the answer is I can just multiply by a constant. So for instance, if I wanted to use g of x and multiply everything through by a 2, I'll have 2x cubed minus 12x squared plus 8x plus 80. That's another answer. All I did was multiply by 2. If you want to multiply through by 1/2, you can do that as well. Multiply through by negative 3. That will give you another answer. As you can see, there are infinitely many answers to this problem. I hope that was helpful. Thanks.